In January of 1920, I opened Ramanujan's last letter, and I saw mathematics that should not exist. The handwriting was shaking. The paper was thin. The man who sent it was dying in India, and he knew it. He was 32 years old. He had no degree, no formal training. He had worked as a clerk, earning £20 a year. And yet, inside that envelope were 17 mathematical functions that I, a professor at Cambridge, a fellow of the Royal Society, could not understand. Not because they were wrong, because they were too far ahead. It would take the rest of the world 100 years to catch up with what this dying man had written. His formulas now appear in the study of black holes, in string theory, in quantum gravity, sciences that did not even exist when he put pen to paper. A clerk from southern India with 3 months to live had looked over the edge of death and sent back the future of mathematics. My name is G.H. Hardy. I opened that letter, and what I saw inside changed everything I believed about the human mind. This is that story. But to tell you about the letter, I must first tell you about the man. And that story begins 7 years earlier, with a different letter, the one that changed my life. In late January of 1913, I found an envelope in my mail at Trinity College, Cambridge. It was from Madras, India. The handwriting was neat, but unfamiliar. Inside was a letter from a young man I had never heard of. He introduced himself politely. He said he was a clerk at the Madras Port Trust. He said he had no university education. And then, almost apologetically, he asked me to look at the 9 pages of mathematical formulas he had enclosed. I nearly threw it away. You must understand, mathematicians at Cambridge received letters like this regularly. Amateurs who believed they had solved great problems. Cranks. Enthusiasts. Almost always, their work was either trivial or wrong. I expected the same. I did not get the same. That evening, after dinner, I sat down with Littlewood, and we began to read. By the end of the first page, I was interested. By the 3rd page, I was disturbed. By the 9th page, I was certain that we were looking at the work of a man of genius. There were roughly 120 results in those pages. Some of his formulas were familiar, some were new, but once we saw them, provable. But some, and this is what I still cannot explain, were so strange, so alien, so far beyond anything in our mathematical world that we could not prove them, could not disprove them, and could not understand how any human being could have conceived of them. One formula in particular stopped me cold. It was a series for pi, an infinite sum that converged to the value of pi faster than any formula in the history of mathematics. No mathematician in Europe had ever seen anything like it. When I checked it, it was correct to a degree that was almost offensive. This man, this clerk, working alone in India without access to any modern mathematical library, had surpassed every living mathematician in Europe in the study of infinite series. I remember Littlewood saying to me, "This man is either a fraud or a genius." And I said, a fraud would have to be a mathematician of the highest order to produce forgeries like these. These were not the results of someone who had studied mathematics. These were the results of someone who had seen mathematics, as if the formulas already existed somewhere, and he had simply copied them down. Ramanujan later told me how it happened. He said that the Hindu goddess Namagiri would appear to him in dreams. He said he would see a red screen formed by flowing blood, and a hand would write mathematical equations on it. When he woke, he would copy what he had seen. I am an atheist. I do not believe in goddesses or visions or divine mathematics, but I also could not explain where his results came from. And that contradiction lived inside me for the rest of my life. I wrote back immediately and arranged for him to come to England. It was not easy. Ramanujan was a devout Hindu Brahmin, and crossing the ocean meant breaking a sacred rule. His mother resisted. His community resisted. Eventually, in April 1914, he arrived in Cambridge. He was thin. He was shy. He was vegetarian in a country that barely understood the concept. He had taught himself mathematics from a single old textbook he had borrowed as a teenager. It was a book of nearly 5,000 results listed without proof. Where other students would have been overwhelmed, Ramanujan treated every single result as a challenge. He re-derived them all. Then he went further, far further, into territory the book never imagined. He was so poor as a young man that he could not afford paper. He worked on a slate board, writing formulas with chalk, and when the slate was full, he would wipe it clean with his elbow and start again. Thousands of results. Gone. Written. Verified. Erased. What survived was only what he chose to copy into his notebooks. I often wonder how much was lost on that slate. And now this man was sitting across from me in Cambridge. We began working together immediately. The collaboration was unlike anything I had experienced. Normally, when two mathematicians work together, they operate within the same framework. They share assumptions. They speak the same language. Ramanujan and I did not speak the same language. His mind worked in a way I could not follow. He would present me with a result, a formula, an identity, a relationship between numbers, and when I asked him how he had derived it, he would look at me with genuine confusion, as if asking how one derives the color blue. It was simply there. I once asked him about a particular formula that seemed to come from nowhere. He told me he had known it since he was a boy in Kumbakonam. He said it the way you might say you had always known your mother's face. Let me tell you about one moment that shows exactly who he was. I visited him in the hospital. He had fallen ill, as he often did in England, and I mentioned that my taxi had the number 1729. I said it seemed like a rather dull number. He looked at me and said, without hesitation, "No, Hardy. It is a very interesting number. It is the smallest number that can be expressed as the sum of two cubes in two different ways." He was right. 1729 equals 1 cubed plus 12 cubed, and it also equals 9 cubed plus 10 cubed. He knew this instantly, not because he calculated it, but because he recognized it. The way you recognize a friend's face in a crowd. I sometimes rated mathematicians on a scale. I gave myself 25 out of 100. I gave Littlewood 30. I gave the great David Hilbert 80. I gave Ramanujan 100. But I'm not telling you this story because of his genius. Genius I have seen before. What I have never seen, what no one has ever seen, is what happened when that genius began to die. By 1917, Ramanujan was seriously ill. The English climate was relentless, cold, damp, gray, nothing like the warmth of southern India. The food was impossible for him. He was a strict vegetarian Brahmin. In wartime England had almost nothing he could eat. He cooked for himself in his room, but often he simply did not eat at all. And the loneliness, I did not fully understand it then, but I understand it now. He was the only Indian at Cambridge. He was surrounded by men who respected his mind, but could not understand his world. He missed his mother. He missed his wife. He missed the temples where he had prayed to the goddess who gave him his mathematics. He was admitted to sanatoriums multiple times. He grew thinner. His eyes, which had once been so bright when he spoke about numbers, grew tired. I visited him as often as I could, but I knew I was watching something precious being destroyed by something as mundane as weather and food and distance from home. In 1918, we achieved something remarkable together. Ramanujan was elected a Fellow of the Royal Society, one of the highest honors in science. He was 30 years old. He was one of the youngest fellows in the Society's history. He smiled when I told him, but it was not the smile of a man who felt vindicated. It was the smile of a man who had always known the mathematics was real, and who did not need an institution to confirm it. I needed the confirmation. He never did. A few months later, he was elected a Fellow of Trinity College, the first Indian to receive that honor. I hoped these recognitions would give him a reason to stay. They did not. In 1919, he told me he was going home to India. The doctor said the voyage might kill him. I knew. even if the voyage did not, that India could not give him the medical care he needed. I begged him to stay. I arranged for the best sanatoriums, but he looked at me with those quiet, exhausted eyes and said that he needed to go home. He needed to see his mother. He needed to be near his temples. He needed to hear his own language again. I walked him to the ship. I do not remember what I said. I remember what I felt. It was the feeling of watching something irreplaceable leave the world, slowly, right in front of you, and being unable to stop it. I remember he turned back once, just before boarding. He did not wave. He simply looked at me. And in that look was everything neither of us knew how to say. And then, in January of 1920, the letter arrived. The letter I told you about at the beginning. I knew he was dying. I knew this would be one of the last things he would ever write. And yet, he did not write about death. He did not write about fear. He wrote about mathematics, as if mathematics was the only language in which he could say goodbye. The 17 Mach theta functions he described in that letter. I stared at them for hours. I recognized their beauty immediately, but I could not see where they came from. They did not follow from anything I knew. They did not connect to any framework I understood. They were mathematics from somewhere else. 3 months later, on April 26, 1920, Srinivasa Ramanujan died in Madras. He was 32 years old. I did not attend the funeral. I was in England. I heard the news by telegram. I sat in my room at Trinity College and felt something I had never felt before, and have never felt since. Not grief exactly. Something larger. The sense that a window into another world had been open for a brief moment, and now it had closed forever. For decades, his Mach theta functions remained a mystery. Other mathematicians studied them. Some made partial progress, but no one could fully explain what Ramanujan had discovered on his deathbed. Then, in 1976, something extraordinary happened. A young American mathematician named George Andrews was visiting the library at Trinity College, my own college, searching through old papers in a box of loose, uncatalogued pages that had been sitting there for over 50 years, forgotten by everyone. He found 130 pages of mathematics in Ramanujan's handwriting. It was his lost notebook, written in the final year of his life, while he was dying in Madras, in the same period as his last letter to me. The pages were disorganized. Some were stained. Some were written on the back of other documents, but the mathematics on them was breathtaking. Andrew said later that when he turned the first page, his hands were trembling. He recognized immediately that he was holding results that went far beyond anything the mathematical world had yet understood. It took him years just to catalog what was there, and it took the rest of the mathematical world decades to catch up. What they found was staggering. I told you at the beginning that his formulas now appear in black holes, in string theory, in quantum gravity. But what I did not tell you is how it felt when mathematicians began to realize what Ramanujan had done. It was not excitement, it was something closer to fear. Because it meant that a dying man with no training had seen deeper into the structure of the universe than any living physicist. And no one could explain how. One mathematician said recently that Ramanujan's work keeps appearing in new places, decade after decade, as if his formulas are a language the universe speaks, and we are only now learning to hear it. How? I spent my life asking this question. I never found an answer. Ramanujan believed his mathematics came from the goddess Namagiri. I could not accept that. I am a man of proof. I believe in what can be demonstrated. And yet, I also could not explain how an untrained mind produced results that the entire mathematical world could not understand for 100 years. He once told me, an equation for me has no meaning unless it expresses a thought of God. I told him that was nonsense, that mathematics has no need of God, that proof is its own justification. But now, looking back across all the years and all the minds I have known, I wonder if Ramanujan understood something that I was too rigid to see. Not that God writes mathematics, but that there are truths in the universe that the human mind can sometimes receive rather than derive. That genius, at its highest level, is not calculation. It is recognition. It is seeing what was always there. I once called our collaboration the one romantic incident in my life. People assumed I was being poetic. I was not. I was being precise. In all my years at Cambridge, in all my work, in all my friendships with brilliant men, nothing ever came close to the experience of watching Ramanujan reach into the unknown and return with something no one had ever seen. People sometimes ask me about his last letter. They want to know what it felt like to open it. I will tell you. It felt like receiving a message from the future, written by a man who was about to die, in handwriting that was already trembling, describing things that the rest of us would need a century to understand. That is what I saw when I opened Ramanujan's last letter. Mathematics that should not exist. And yet, it did. I am G.H. Hardy, and I have known only one genius in my life. His name was Srinivasa Ramanujan, and his mind remains the greatest mystery I have ever encountered. Srinivasa Ramanujan, 1887 to 1920. His lost notebook is still revealing new mathematics today.